All right, sweet. So we've had some awesome talks already. Super glad to be here today. I'm going to be wrapping things up with my talk, leveraging interfaces and GraphQL schema design. A little bit about myself. My name is Ryan Canner. I actually live in Denver, Colorado, not San Francisco. But I am super pumped to be here today, not only because it was 8 degrees this morning when I woke up to get in my car to get to the airport to come here, but I'm really excited to give this talk as well. I'm an engineer here at NerdWallet on the content platform team where I work with WordPress and GraphQL and lots of other fun stuff. I'm also a co-organizer of the GraphQL and WordPress meetups in Denver. So if you're ever in town, come on by. On the side, I also help maintain WP GraphQL, which is an open source project bringing GraphQL to WordPress. In my free time, I like to hang out with my crazy dog, Blake. She is nuts, has way too much energy, and I'm a huge baseball fan. Go Yankees. Something else about me is that I love pizza. Now, I love pizza, probably to like an unhealthy amount. Like it's my favorite food group type of obsession. You know, thin crust, Sicilian, deep dish, you name it. If it has cheese, sauce, and dough, I'm there. Now, as you could probably tell, since I'm standing up here in a room of my peers talking about my favorite pizzas, I've hit kind of like the pinnacle of software engineering, I think, at least for my own career. I've hit all my goals at this point. So that's kind of given me this feeling deep down inside that I'm missing something, that I'm not using, you know, my skills to their full potential. And that's when I got thinking of what I really want to do with all my skills. And that's when I decided I wanted to be the best damn pizza man in this land. Now, when I start thinking about this dream of mine, I think, you know, I could start small, you know, open up a couple of local pizza shops, self-direct and produce a very low budget commercial airing on public access, get one of those logos that like is a magnet sticker onto your car, definitely dump way too much money into the white pages for advertisement. And then once I've gotten to that point, think about how can I grow this dream of mine? How can I really be the greatest pizza man there is? And that's when I started thinking, I need to combine what I know with what I love. And that's how I plan on getting to the pinnacle of my dream, which is Pizza QL. Now, the best way to scale my business, to really get into, you know, those that Papa John's type of dough, my plan is to create a website to open up access to my wonderful pizza to people outside of my local community. So I'd start out small, come up with a specials board, you know, throw up a couple things that, you know, I really like. I love buffalo chicken pizza. It's one of my favorites. Throw that up there so other people can enjoy this as well. So then I start thinking, well, how do I build this? How do I start modeling this data? And what I have now is, it's pretty simple. It's pretty easy, right? I have a pizza. Pizza has some attributes, you know. All pizza has sauce. All pizza has cheese and toppings. And then I can write my query and return an array of pizza types. Boom, I'm done. Easy to do, right? You can see how all of these fields map. I now have a GraphQL model representing what my UI should look like. But now things get a little more complicated because I've discovered that I make the best garlic knots that anyone has ever had. So naturally I decided this needs to be on my homepage. I need to start pushing these garlic knots. People need to know about these garlic knots. But hold on, this creates a problem for me. See, garlic knots are not pizza, right? There's no toppings, it's a different thing. So my model that I had for pizza before, it's just not gonna work. So I need to come up with a different type entirely to model this data. So I come up with 2 different types. I have my pizza type to model all of my data about my wonderful, delicious pizzas. And then I come up with a side type to model all of my sides. Now, to query all of this data at once, the way I plan on doing this is with a GraphQL interface. That's how I'm going to tie this all together. So what are interfaces anyway? John Travolta doesn't know, that's for sure. An interface is an abstract type that includes a certain set of fields that a type must include to implement that interface. Right? Interfaces are not a new concept in software engineering. They've been around in very old programming languages, and they also show up in GraphQL as well. The way I like to think about it within GraphQL is, your schema becomes the contract between your server and your client, saying, this is the shape of the data that I'm going to deliver to you, Mr. Client. And interfaces within your schema have that same sort of contract, but between your types that say, any type that implement this interface also need to have these fields, which creates another level of predictability within your graph. So as for how this actually works within the GraphQL language, you have this keyword implements. So on any type that you have, you can implement a type like so. And then it's expected that any fields and the way they're defined on your interface then need to come over to the type itself. So if a certain field is supposed to return a string, then any type implementing that interface needs to have that field returning the type of string. Now, there's still room for some self-expression for these types because they still want to be their own thing. So a pizza can still have toppings and a side can still have quantity. So when querying interfaces, this is where the power of interfaces really comes to show in the GraphQL spec. At least I think so. So something special about interfaces is that within the spec, anytime you query an interface or a union, you have this type name field that you can query as well. A lot of tooling within the community relies on this to build cool things like Apollo. So this type name will return the name of the type that's actually being queried. So because our query returns an interface, it can return any type that implements that interface as well. So in our specials query, we're returning our food item interface. And at the top level of that query, we can query for any of the top level fields that are within that interface itself. And these fields will be plucked out of the response for any type that implements this interface. Then we can use these really cool things called inline fragments. So fragments are this idea of a tiny piece of your query that is just like in this little box. And inline fragments can be used within the larger scope of the query itself. So in this instance, we have an inline fragment on the pizza type. So pizza is one of the types that implement food item. So whenever the query response gets a pizza type back, it will grab the toppings field out of the response from the schema. And then the same thing will be done for side as well. The way I think about this is kind of like a switch statement within your query. So as the query is executing, it'll say, what type is this? If it matches one of your inline fragments, it will grab the fields for that type. Now, we can look at an example of this here. This tool is called GraphQL Faker, if you're interested, unless you like mock up GraphQL schema really quickly. It's pretty cool. So this is the schema we were just looking at. So as you can see, the response of that, we have a couple, let's, okay, come on. All sides, snake eyes, there we go. So we have a mixture of different types. So we can return sides and we can also return pizza. So we'll grab all of the fields that we need from the interface itself, and then we can grab, toppings if it's a pizza that's returned, or we can return quantity if it's a side. Now, if you've used GraphQL before and written queries, you might have used unions and might be thinking, unions do this, right? Well, yes, they do. Unions allow you to combine two types together so that when you return a union, you can query for fields on either one of the types within a union. So let's take a look at what that looks like. So you'll see the big difference here is that there's no intersection between the types. So the way I think about unions is it's just like a kind of like a parent umbrella for your types. So there's no intersection. It's just showing like what the possible return types for it can be. So we can run this, and the response is essentially the same. It's the same shape we're getting back, but again, we have to write out every field we want on every single type. Now, in a small example like this, it's not such a big deal, but when your graph starts growing and you have hundreds of fields on types and have a lot of instances where you have many types overlapping, this can become an issue very, very quickly. Now, another important distinction between interfaces and unions is that there's more predictability within unions, because a union says you can only return this type, and this type, whatever types you have listed within the union. But with an interface, it can return any type that implements that interface. So as your graph grows, that can become problematic, because if you don't control both sides of your integration, so say your backend team introduces a new type that implements a certain interface that you're using on your client, and you're not expecting that data to come through, that puts you in a situation where you need to be coding a little more defensively in the client rather than when using unions. So it's something to think about and is very dependent on your particular implementation. Now, this is the difference of unions and interfaces visualized. That, like, this is for me what kind of made me like really understand the difference, where interfaces have this overlap between types, where common fields between them can be queried on the interface itself, whereas unions are just separate standalone types that are just held together by this umbrella. Now, let's look at something a little more complex, because when you start growing your graph and your implementations, things start getting more complicated pretty quickly. So the world knows about my world famous garlic knots at this point. They know they're amazing. The thing that's really starting to start to catch on is my PizzaQL t-shirt that I've been pumping on Twitter. So I decided this needs to go on the special boards. I need to move this t-shirt. The problem is t-shirts are not garlic knots, and they are not pizza, unfortunately. So we end up in this place where we now have 3 bespoke types that we're trying to return on the specials board. I think to myself, oh my God, how am I gonna do this? I figured out 2 types, I got over that barrier, I related everything together, but now I have these 3 bespoke types that are like kind of similar and also kind of not. So I end up in this place where I start looking at what overlaps between these 3 things. So when I start looking at it, I see everything has an ID, everything has a name, an image, and a price. Okay, that's some common fields, I can work with that. Then I also see, well, everything that I sell that's like a food thing has sauce and cheese. So the way I'm gonna handle this is by using multiple interfaces. So in GraphQL schema design, you can actually implement multiple interfaces onto a type itself. The way that works is by separating them with an ampersand. So in this case, we have the pizza and side type, and both of them implement the food item and product interface. So what this means is that each of them inherit the fields from both of those interfaces. So in this instance, they get sauce and cheese from food item, and then they'll get ID, name, price, image from product. And then we also have the third type, apparel, that also gets those fields as well. And all of these types can continue on being their own types and having their own fields. Obviously, in this example, they have 1, but that's mostly so code can fit on the screen rather than any other good reason. Now what we can do with our query is really, really freaking cool. And in my opinion, I get jazzed about it. Is that we can query interfaces inside of interfaces. So we're making Exhibit proud here. So where we're gonna start on this, our specials query has changed. So now it's gonna return the product type, or the product interface, which again is the interface that is shared across all 3 of our types. So on there, we can query for the common fields, ID, name, and price. Then we can also query for fields on the food item interface. So we can query once for things like sauce and cheese for our two types that implement this interface. Because GraphQL is a strongly typed language and it always knows the type that's being returned, it can then figure out that, okay, I know that the pizza type is being returned here. This type implements the food item interface. So I look for this inline fragment, and then I query for those fields. Then we have our inline fragments to get the individual fields off of the individual types that are unique to them. And we have all of our data in one beautiful, magnificent, amazing query. Now, what this kind of looks and feels like, too much. Let's see. So now we can, let's see if we can get everything. Nope. Roll the dice. This just like randomly returns types. So it's like kind of a crapshoot trying to get, oh, this one did it. Okay. So in this response, we get an object back that's the apparel type. We get one back that's a side, and one that's a pizza. So within the single query, we can query things across our graph all at once, and we can have all of these fields that we need to query in a nice, like tightly coupled package, which is really nice when you get into component development. So when we start looking at the component mappings for this, when we start building the front end, how are we going to parse this all out in a way that makes sense? We can start, right? We have a product card, pretty standard thing, our high level kind of component. And in that component, we're going to have a fragment. So this is the other kind of fragment that I was talking about earlier. Inline fragments are used in line with your query. Standalone fragments can become reusable chunks of a query. So we have a fragment on our product interface, and there we can query all the fields we need within the product interface. Next, within a lower level type, we can query for all the fields we need on the food item interface. So that becomes this food fields fragment that will then get hoisted up to the main query. And same thing goes for apparel fields. We can have apparel details component that has this query chunk very, very tightly coupled. So the important thing, the thing that interfaces really empowers here is it lets you forget about like distinct types within your type system and lets you think more about like what data do I need to hydrate this component? Like these particular product cards, like I could start selling mattresses tomorrow and like still want them to show up this way. And a mattress is still gonna have a sale price, an ID, a picture, and all these things. So by querying my interfaces, I can start scaling that super easily. And then when I tightly couple my fragments with my components, they're really caring about the raw data that they're getting, not so much about like the properties on this very specific thing, but a component will be like, well, I need a URL, an alt, and a image width to render an image. I don't care what type it's coming from, as long as it implements this interface. I know that it will have these fields because of the strongly typed system that GraphQL has. Now, a little fun thing, we've talked a lot about, how to make this easy to do in GraphQL. I like to kind of put this into perspective, especially when I've been working with GraphQL for quite a long time. When I start thinking about, well, like, how would I do this with REST? And like, you're back to this, where you're like, well, I got to hit all these 3 different endpoints. It's going to return a whole bunch of data that I don't really need, and they're going to be in like totally different shapes. And when you start looking at this versus the power of something like this, it very quickly starts to feel like you're in the dark ages again. Okay, so some takeaways. Interfaces help bring your types together, and they make your graph more flexible. The thing to remember is that while you implement all of this, you can still use everything like the exact same way you were. So every step of this process I walked through where I was like, okay, we're gonna query for only pizza types and return an array of them, implementing interfaces, doing all of the stuff that I showed you, you can still do step 1. So if there's another piece of your application where you only need pizzas, then you can only request pizzas and get your pizzas back. It also makes your components more reusable. Again, when you start thinking about the data you need to hydrate them and stop worrying about what this thing actually is, you can then start turning out things way quicker because your components will be more reusable. Using multiple interfaces is like one of my favorite cool little like GraphQL schema design trick. I highly recommend you start messing around with it. I think they unlock really, really powerful query combinations. A thing to remember is the trade-off of using interfaces and understanding that you may need to code a little more defensively in your client. So I encourage you to think about your implementation long and hard. Think about if that's the right decision for your product. And finally, PizzaQL for life. Thank you so much. If anyone has any questions, feel free to ask. Otherwise, I'll be hanging around. Come talk to me. Yeah. Yes.
Can you give more detail on coding defensively on the client when you're using interfaces?
Sorry, can you say that again?
When using interfaces, you mentioned coding defensively on the client. Can you go into more detail?
Perfect. Yes.
I had to throw my own joke in there.
So coding defensively on the client, I think is very important, especially when you start doing things like this, because as you introduce more things into your schema, you'll start introducing new types, and they will implement the same interface that's being used in the query somewhere in your client. So within your schema, you could have a query that returns a particular interface, and a client could be like, okay, great, I need these 3 types that are all bound by this one interface. That's what I want for this very specific component. I want these 3 things. Cool. So they write their query, they're getting those things back, and then all of a sudden, if you don't control both sides of your integration, someone could say, okay, I'm going to introduce this new type that also should implement this interface. Then they do that, and then all of a sudden the client is getting this new type that they didn't expect. So it will start showing up in their query in a place where they're not expecting it. So that's a big difference between interfaces and unions, where unions is you will get these types and nothing else. It's very specific, whereas interfaces are a lot more open, where they say anything that implements this can be returned. Yeah.
How would TypeScript play into that as a follow-up?
I have no idea because I mostly write PHP.
Okay, what's your favorite pizza spot?
Oh man, favorite pizza spot in the US? Oh my God, I've got to like pull out my notebook. That is a great question. Yeah, PizzaQL is definitely is number 1. Come on, good catch. Beyond that, I mean, it's like my hometown like spot that like no one's ever heard of. That's like super small and like everyone's mean to you. Like that's my spot. Like like, yeah. Fratelli's. Yeah. I mean, like you could Google it. You probably won't. I don't think they have. They're probably still in the white pages at this point. They have not risen to the level of like, success that PizzaQL has gotten to, because they haven't harnessed the power of GraphQL. So, anyone else?
I have a question. Oh, it's really loud. I was wondering about, and I think I kind of garnered this a bit from your clarification, but I wanted to also circle back. Is there a cost to retroactively introducing interfaces into types that already exist?
No. So that's the other cool thing, right? Like you can get to this point, start growing your graph, just get things up there, start spinning out types, and then you can get to a point where it's like, okay, let's take a step back, see what we have, look at like what is overlapping, like what are the similarities here, and what makes sense to start codifying this into a single interface so that you can unlock stuff like this. So I think if you are at that point where you're like more greenfield and you're like, let's get this going, get up and running, like go for it. Don't stop and like try and make all these big decisions and like plan out 10 miles ahead when you're like on step 2. So introducing them after the fact, I think, is actually, it's probably a very good way to go about it, because you have a better idea of like where's your graph at, and like where are those intersections between your types. Sweet.
What are those triangular things on your shirt?
They're these pretty awesome things. They're slices of pizza, which I had this already, and like I actually, like, this did not inspire the talk at all. It was like I was in the middle of writing this, and I was like, I think I have something for this, and I did, which was pretty cool. So yeah. Cool. Yeah, what he said. That. Awesome. Sweet. Thanks, guys.